you have a 10,000 dimensional problem, you can create up to 10,000 principal components. Obviously, that is badly missing the point of PCA, which is that we want to reduce dimensions. So, how many principal components do we need? That is a question without an answer. There are at least a half dozen conventions that we use to decide how many components we need, and they all contradict each other. So it's really on a problem by problem basis. Is Do you have enough data to accurately answer the question you are trying to answer? Um, as far as benchmarks go, sometimes you hear that you want to explain 70 to 80% of the data. I don't know how widely accepted that is. It sort of feels like one of those cases where someone said it, and then someone else cited them, and then someone else cited the third person, and now it's in the literature, even though it was just somebody giving a rule of thumb in a paper 20 years ago. There's something called a Scree plot that we could use. A Scree plot looks like this, and I'll show you it in Python. It's easy to generate. Every principal component explains less variance than the one before it. That's how PCA works. So if you graph the principal component versus the explained variance, it's always going down. And this graph is called a Scree plot. And the theory behind a Scree plot, let me see if I can get this in the video, not super well, but think of this graph as an arm. You've got your arm down and then you've bent it at the elbow. And the theory of the Scree plot is that you find the elbow on this graph and you keep the principal components to the left of the elbow. And this is a judgment call. I would say the elbow is maybe at the fifth principal component. Um, Although Scree plots are famous, it's been suggested that using the Scree plots tends to underestimate the number of principal components you want. Like here, if I put the here is explaining the total variance, so it's going up because with each additional component, we get extra information. The Scree plot would put us around here with something like 38, 39% of the variance explained. Obviously, if you took the 70% I gave you earlier seriously, this is way less than 70%. But also the Scree plot looking for the elbow and the 70%, those are just general guidelines. In practice, when you do PCA, you're going to be experimenting and seeing what happens with different numbers of components because there is no one size fits all answer. And I'll throw this pie document onto Canvas for you, but or maybe I'll just copy and paste the relevant part, since again you don't have the EPUB documents. But there are built-in commands that will give us the amount of variance that a component explains. And once you have this, generating the Scree plot, well, you're just graphing the component on X versus the amount of variance it explains on Y.